So you said they're isomers of one another. That is true. Because how many carbons do these all have? 9. But are they all nonane compounds? No, you're shaking your head. No, that is correct. They are all isomers of one another. But is nonane even up there? Where's nonane? Well, you could just, if you say that one, you know, I wasn't paying enough attention. I'm not that quick and smart to catch up. I just saw, is it that one? Someone did say it, top and right. Okay. So if that is the case, which it is, okay, this is nonane right here. What could be the most common mistake that someone might make? Say this is octane and say 1-methyl octane. That is not the case. This is nonane. Okay, so is this teal? What do you call this? Tiffany? Okay, so brown, Tiffany, or blue? Who's next? Okay, so brown. All right. The first thing, this is the hardest one up here probably. Okay. So what is true about this one? How many carbons are in the parent chain? There's 7. Okay. Can you go in more than one direction? Yes. Okay. So if that is the case, the simplest way to do these is just start from left to right and say, okay, 1, 2, 3, 4, 5, 6, 7, okay? Or you could go 1, 2, 3, 4, 5, 6, 7, all right? So again, you can say this is a branched chain, okay, where it branches off of there, or that's probably the simplest way to look at this. But now you got to think golf, okay? So we've established that it's 7 carbons. So what is the name of that? What's the prefix for 7? Okay, so I gotta write this really small. Heptane. Okay, so is there anything branching off of that heptane? Yes. So now we come up with that term derivatives. How did we explain what a derivative was yesterday? Stannate, ferrous, plumbum. Those are all what? Those are all metals on the periodic table, but you don't know them as metals because they're Latin terms for what that's standing for. So ferrous means iron, plumbum means lead, and then stannate means tin. Okay? So they're all derived from a Latin term. So when we look at this, we said yesterday X marks the spot right here. Okay? Now, this is not a hydrogen atom, right? You would agree with that, correct? Okay? So these are, because it doesn't say anything other than that, but here it does. You can write these in, but it's not necessary. Okay? So this is a carbon-to-carbon bond. So the formula for that is what? C2. And the rest of these dashes or sticks are what? No. Okay? And when we do that, C2H6 means you've got ethane, but C2H5 means you have what? An ethyl group. Okay? So, with that, where is that ethyl group located? 1, 2, 3, 4, 5. 5 ethyl heptane. No. Who says no? 1. Is that 2, 3, 4, 5, 6? Yeah. Good job, 6. What's the... Used to be a movie, was it Magnificent 7? Why can't we have one more person raise their hand? Then you could be the Magnificent 7. 1, 2, 3, 4, 5, 6. I can't remember who all had their hands up. But why can't this be 5-ethyl heptane? How many people think golf is boring? You see, now some of the hands go up. What's the goal in golf? To get the lowest score, right? So when we do this, we don't want 5. We're going to go in this direction and say what instead? 3. Okay? So we've got 3 dash what? Okay, 3-ethyl heptane. All right. Okay, so are we good with them top 2? Can we erase those top 2? Well, this one we can, because that's just plain nonane. Some of you are probably thinking this is just plain nonsense. See, I won't even have my back blur. I have my back to you, so some of you can just have one of them. Aha, that's funny. So can this other one be erased? Okay? So, blue or Tiffany? Okay, I heard Tiffany first. Okay, so what's the parent chain for this guy? Gal, whatever. Tiffany's not a guy, so. Now, help me out here. Is Tiffany really a color? Okay, I'll buy that. Okay, parent chain is what? So what's that prefix? Okay, is there anything branching off of that octane? X marks the spot. Okay, this is a carbon-to-carbon bond, so that has a formula CH3, which is what? Methyl. And where's that methyl group located? Methyl octane. Okay? That's right. So how many of you have got, you probably could have wrote that one out correct. How many of you did have 2-methyl octane? And if you're one that I want to raise my hand and say, yeah, I understand this stuff. If you, I'll find out soon enough whether you understand it now or later. So if you're not being honest with yourself, you're really not doing yourself any favors. Okay? So 2-methyl octane. Can we get rid of Tiffany? Not. Get rid of. Okay? Fair enough. Okay. How many you think that could be just a lit? This one's probably the hardest one. Okay? So when you look at it, the parent chain is what? Okay? And I'm just curious how many others think that it's not 8, but how many of you would have thought that it was 8? Okay? It's actually how many? Okay? So one of the 2 ways that we can do that, so we got heptane. Okay? So the easiest is to go 1, 2, 3, 4, 5, 6, 7. If you went this way, you'd have to go 1, 2, 3, 4, 5, 6, 7. Okay? So regardless, it's still going to be a 7-carbon compound. Okay? Now, how do we show where these groups located? We say what marks the spot. Okay, so we've got one here and we've got one here. So can these go from right to left? Yeah, sure. We've seen that in your first example. Or second one, we said this one was nonane and then this was an octane molecule. Or excuse me, a heptane because it had an ethyl group. Okay, so where are them 2 X's located? 2 and 3. Okay, so what that means is we need to illustrate where they are located. We've got 2, 3, okay? So we know triangle, that means you would have 3 derivatives. But if you only have 2, okay, it's a prefix. You would think that would mean bimethyl, kind of like a bicycle, but that's not the case. It's a different prefix. Does anyone think they might know what that could be? Just take a guess, and you might just hit the dartboard. Like if you were to do that in Spanish, close to a Spanish term. What's 2? Okay, now you're getting closer. Well, it still has to be 2. It's actually di in 2. Okay, so 2 comma 3 dimethyl. Okay. Oh, there should be a dash here. 2 comma 3 dash dimethyl. Okay. Because some of these are going to be becoming more complex, and like I said, we're trying to meet you halfway. Because yes, it is April. I get that, but we still have a job to do. And let's go ahead and let's win this by a touchdown rather than having to win by a field goal. Okay. Can we erase this? All right. So some of you were putting some very valid terms on that paper. Some of you put hydrocarbons. Yes, that's true. Some of you had put an even better term on there that started with S. Because each one of those was saturated. That's exactly true. Okay? And so I said, if worse comes to worse, we would take that. So how brutal would that have been? 5 points apiece. How many 15s out of 20s would we have had? 20s? 10s? 5 points apiece. So how many of you got 1 right? 2 right. 3 right. Okay, that's where we're starting to teeter-totter. And I wouldn't have expected you to get all 4 right. That's why, grabbing your attention. Okay, so if we are talking about an unsaturated compound, saturated means they're all alkanes. But if it's unsaturated, it might mean what? Okay, so the difference between those two, what's an alkene? It means there's something present in that double bond. Okay, so is there such a thing? Let's draw methane. Who wants to draw methane? Nobody? Is that even possible? No, it's not possible. You have to have at least 2 carbons to double bond with one another. Okay, so someone pick a number between 4 and 10. 4. Okay. Okay. So, and you don't even have to draw this if you don't want, because you probably have this wrote down somewhere. So if we're saying this is going to be a double bond, well, we'll go triple bond instead. Okay? So, 1, 2, or 3? Okay, would 3 even? 3 is not possible. So, with that, okay, do you want 1 or 2? Okay, so 2 we had heard. So the simplest way to do this is going from left to right. Okay, what is the prefix even if we did not put anything past this? The parent chain is what? Okay, we know that this is BUT. Okay, regardless, but we said there's a triple bond, and you had picked what number? 2. So after this second carbon, you're going to put a what? Okay? Now, the suffix for a triple bond is not ane. We just finished those. That's an alkane. This is a what? Yne, because it's an alkyne. So, Yne, okay? Can we just leave it written like this? We can connect these now. Okay, how many hydrogens does this guy have to have? How many hydrogens this one? 0. How many hydrogens for this one? 0. How many hydrogens for this one? 3. Kind of a low down dirty trick on my part. Why can't these two have anything else bonded to them? Yeah, they're already full. Okay? So with that, the only thing we have left to do is write what? Just a number, and that number is what? Number 2. Okay? So what we mean by that, if you don't put anything after that number, you're just saying where a bond is located. Like in your prior examples, noticed it had said 3-ethyl. It said 2-methyl. If you write something after the number, then you're saying there's a type of derivative located on there. But if you don't have anything written, okay, so an example for that would be, just keep this simple. So what we mean by that, on the second carbon, we've got this methyl group located. Okay. So again, if there's nothing written after that number, you're just saying where that bond is located. Notice after this number, you're saying methyl as a derivative. Right there it is. Okay. Does everyone understand the difference between these two? Left outside, are we on the bus so far? Left middle. Okay, middle. 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 Okay, right middle. Right outside. See, even how we started class, this doesn't seem like this is that difficult. Now we're all on the bus, right? Who's driving? Are we gonna, do you want to drive? Okay. Watch the tail swing on that. What do you suppose that means? You gotta take a wide corner from time to time, and when you do that, the tail end of that bus can swing out further than what you think. Okay. Well, so that is a triple bond. See here, we wanted to talk about what? Multiple bonds today, so we've done that. Okay. I think we're doing too much talking in here because it's getting too much hot air. Does that mean I need to shut up from here on out? Just no more? You had enough for today? No. You know, see, some of you farmers, you're lucky. Just for convenience sake, some of you probably still put square bales in the barn, right? Little bales like this that you get to chuck. Is that anybody in here? No, but, and that's possible too. No one puts square bales. Okay. So you just think you're done, and oh man, here comes another rack. And do you want to be outside in the open air, putting them on the elevator, or you want to be up in the barn with someone else and stacking them? There's a couple of reasons why. Then you're only doing every other bale rather than every bale. Is that what you were thinking? Okay. Okay. So, so we've done isomers. We've done alkynes. We've done alkanes. And let's just do one more alkene. So let's go ahead and try something like, is that even possible? Okay, we want you to reverse engineer this, okay? And what that means, okay, let's work right to left, okay? So this is telling you the organic family. So somewhere there is a what? Double bond. This is telling you something very specific too, and that is what? It's a prefix. So we need okay. Now, on this 2, there's nothing written after. It's just a dash. So what do you suppose that is referring to? So that is referring to this guy. Okay? So after this 2, there's a what? And a methyl group means, what's the formula for a methyl group? CH3. Okay, so do we want to work left to right or right to left? Left to right, okay? So let's go ahead and start linking some of these together. Why did that one go a little higher than the other ones? That's where the double bond is, okay? So now we're getting closer. So since these are all single bonds, how many hydrogens would they get? Except for this one. No. That was a low down dirty trick on my part. Okay. This one gets 3. Okay. So why, you said it with the exception of this one, why can't this one have 2? Because there's 1, 2, 3, and 4 there. Okay. This one, does he get 1 or 2 hydrogens? 2? Okay. And this one gets 3. Okay? You're laughing. Why is that? That's wrong. Oh, like in football. Coaches, you're wrong. No, you wouldn't do that. But sometimes it is possible. We're all human. Okay, so with that, how do you want me to change that? You tell me, I'm working left to right, you tell me when to stop. Now, what? Yeah, yep. Okay, now is that right? Again. We're still missing something though. Okay? So, can we just do this? No? Why can't we do this? Have to put what around it? This is actually the same thing. Yes. Yep. Because it's got 3 hydrogens, right? Okay. Well, that's the same as well. One of the things we tell the organic students, you're always going to be right if you do the structural formula, because that was a molecular formula, CH3. If you draw the structural formula with just the dashes, you'll never go wrong with that. Okay, So, okay, alkene, there's a double bond located somewhere on a 6-carbon compound. That double bond is after the second carbon. There's a methyl group located on the second carbon as well. So that's got to be right. Okay, we're moving closer and closer to accomplishing a lot of the goals that we need, because at some point we'll be doing things like that. And don't say, I have no idea what that is. Well, of course you don't, because we haven't taught you that yet. Okay? It'll be about like saying blue 42 striker on the left side going down the sidelines. What type of play is that? Well, you don't know. You haven't learned it yet. Of course, you would never use that. But. All right. So, that is it for today. We'll catch up with you next time.